So here's an example of how I might test a breakfast supplement to see if it causes or increases weight gain. So I have 30 subjects, they're the rats, and I want to divide them, of course, into two groups. If I don't have an old breakfast supplement, then I'll give them a placebo. So before I begin, I know I have 30, and I must randomly assign into my two groups. And we will need some explanation of how, so you'll tell me how to do that. We can go back and add that piece later. So I'm going to give one the supplement, so breakfast, and then the other one gets a placebo, or it might be the old supplement. Either one. Depends on what I'm testing against. And of course, in this upper one, I'm going to put 15 rats. And in this lower one, I'm going to put 15 rats because I'd like to make my groups equal. And so then after they have the supplement and their placebo for a little while, I am going to compare, and I'm looking to see if there's weight gain. And that's how I draw it out. So this notion of randomization and why I do it is I would like to make the groups as similar as possible before treatment is applied. So if I randomly assign, it means I'm not creating any bias, so that hopefully I have some of every type of person or subject in each of the two groups. So for example, if I were looking back up here, I would have, some fat rats, some skinny rats in both groups because I randomly selected that. So it makes those groups similar before I do the treatment. And then by comparing, it ensures that influences other than the treatment operate equally. So in other words, because I'm comparing these two groups and I'm giving them each something, even if it's a placebo, it means that the only difference between the two groups is that one is getting a supplement and one is getting a placebo. So hopefully, if my treatment is working, then I should notice a higher weight gain for those rats. And this is what says, oh, well, as long as you treat them both the same, so treat the groups the same, except for the treatment. And then when you get results at the end, you'll be like, oh my gosh, I treated them the same, except for the treatment. So it must be the treatment that made the difference. Hopefully that makes sense. Okay? And so while I'm figuring out, oh my gosh, it must be the treatment, of course there is the possibility that somehow, even letting the hamsters help me pick randomly, there's the possibility, although very small, that I could have gotten all the skinny rats in one group and all the fat rats in another group. And so it's possible that the random assignment is responsible for making a noticeable difference in the treatment. So I'm going to say that the likelihood of that happening is very slim, and we are going to look at a probability model to check that likeliness, which will allow us then to rule out, oh, chance random assignment. Yeah, we know there's a possibility that happens, but here's the number for that probably happening. And therefore, since it's so low, we have to assume, oh my gosh, it must have been the treatment. And so in order to make the effect, the chance average out, we just use enough units to reduce that variation. In other words, we try to replicate so that we get rid of all those chance random assignments messing up our results.